trying to figure out what.
Yes, x minus a number, a certain number, gives out 8x in the.
Exactly. So in other words, I know what should finally turn out to be, I'm just put that in there. It should eventually turn out to be, when I finally use my technique, it should eventually give me this. Because that's what I want. That's true, I know what I want. I want this turned into, on the left-hand side, that. And I want the other side to be eventually 25. But I'm saying, what must I do to the original to make it turn into that? And he's got me on the right track here. Any ideas? It's a little different, that's why I saved it for last. Yes?
If you have x minus 4 squared, and you expand that, you're not going to immediately get x squared minus 8 minus 9.
Here, hang on. Beautiful. She says, Professor, you expand this thing out, you're going to get x squared minus 8x plus 16. Professor, you have the x squared minus 8x. You don't have the 16. Is that what's missing? She says, I'm missing a 16. If I had a 16 there, maybe I could do something with it. Is that true?
Yes.
Okay, I'll show you the technique. They want you to do this. They want you to isolate the terms that contain the x, that she's doing for me, and determine what it's going to take. I'll put a blank there. 9 moved over, blank again on the side, keep it balanced. They're saying, please come up with a number you can place here and get that, what was it, 16 that I need. And she says, Professor, you need a 16 here. But if you place it here, you gotta place it here. Keep it balanced. Would that now take me back to this? Would that now take me back to here, and then I could deal with it again and get the same answers? Is that true? Now, I'll give you another one here on the side. If it looked like this. Now, let's throw some numbers at you. And I'm going to do it by completion of the square. I'm going to take her beautiful suggestion she gave me. She said, Professor, you've got to come up with something that you're going to add to each side. And you got to put it on both sides to keep this thing balanced. To make it work. Last time, it was merely a 16 that made it work. 16 took it right back. Where to go? Does anyone think they know what it's going to take here to make this turn out to be some square that looks like that? Like here on that one. Now this is the discussion I need. I need to know what should I place on that plane. Last time it was 16. What is it this time? So I can factor this left-hand side into a nice, perfect square. Not going to be the same square as this one, but a nice, perfect square. Now I'm going to throw some numbers at you. Now get some ideas from students. I see some hands going up, which I love. Hang on just 1 second. Could I just not random? 3 or 4. I'm desperate. 3 or 4. Now, would that now factor into a nice perfect square? Was that 3 there? No, that thing will not turn into a nice perfect square. I would go, what number is going to take to get a nice perfect square? 4 is not going to do it for me. That's the wrong number. I'll tell you in advance, 5. If you randomly try 5 on each side, 5 is not going to make the left-hand side a nice perfect square. This one's tougher. This one's tougher to do than this one. Now I saw some hands going up. Let me get back to my student some input. Yes?
Wouldn't it be 9 over 4?
Whoa, hang on. Of all numbers, you give me 9 over 4. 9 over 4.
You want me to explain how I
No, hang on. I tried 4. I said don't try 5. I was just randomly put numbers there. And all of a sudden, out of the blue, he said, Professor, put a 9 over 4. I'll put it on this side also. Now, if he's correct, someone in this clever class tonight, tell me, is the left-hand side now, did he make it a perfect square for me by placing of all numbers? He says, Professor, the only number in the universe to make this happen on this problem is 9/4. Anyone tell me what this right here is? Like up here, it takes subtract 4. What is it here? It should be a nice perfect square if he gave me the right number. This was tough. What is it? I heard x subtract how much? Look at this. He's made the left-hand side a perfect square. You said, Professor, really? Let's check. Let's check his number. If I expand this thing out, guys, x subtract 3/2, if he's correct, times x subtract 3/2, what it means to do, square it. And use, keep on using that word FOIL, expand it out. I know these two are x squared. That's no problem. Checks. I know these terms, that's a -3.